everyone. Today we've got a fun project. We are going to be working on this 2003 club car. It's a resistor cart. As you can see here, we've got the coils, we've got a V-glide. We burned this V-glide out already. That was a lot of fun. This was on fire as well. So this is going to be all upgraded to a solid state control system, just like we did on our 91 club car. It's been phenomenal. Here's the video. I would suggest watching both videos. 91 was the first one I did, and this one I'm going to go far more into depth on how to do it, because I get a lot of questions on different things about how to do it, and so I'm going to try to get a more detailed video made this time. Here's the parts we're going to be putting in here. I decided to try this solenoid this time. This is a club car 48 volt solenoid. I put a resistor on there. So we're going to be putting that in there. We're going to be putting in this controller. I'm really impressed with how well this one is packaged. It comes with a nice foam wrap on there. See, that's a 36 to 48 volt solid state controller right there. So that'll be going in. And I'm going to play with a couple different potentiometers on here. I've got the pop box like we did on our 91. We know that works. I'm going to try something new. Here I've got the M-Core 4 conversion kit. Comes with your M-Core 4, a bar. This is going to go around the accelerator pedal to turn that. Some other adapter piece that goes on. Some conversion wires. A spring that's going to go on here somewhere. I'm not quite sure. Some instructions. So hopefully this works on this golf cart, and if so, that's the one we're going to be using. So before I get started, I'm actually going to hook all this up and do a bench test, and I'm going to go through some of the things that go wrong with it, with the controller and voltages and different things like that. So we'll do that right now. So in my first video, I hooked everything up and it worked perfectly and I had no problems, but I had a few of my subscribers comment on different problems they've had with different things. I'm going to try to answer as many questions as I can that my subscribers have been having with this setup. So let's get to it. We're going to start by testing the pot box. Now I've got an entire set of connectors here. These are automotive waterproof connectors, and I will put a link in the description for these. I went ahead and made up this connector right here that's got the red and the black together there, and the black. So it's just like the pot box wiring here. We'll plug that in. We want the red, furthest out red, right there. We're going to hook to that. Then here you've got, in the middle, you've got the red and the black in the middle. We're going to hook to the black one. And now we're going to hook these to our voltmeter, black to black, red to red. As you can see, we've got our voltmeter on. We are on the 20K ohms setting. Now we're going to push this. This is like pushing your accelerator. You can see those ohms going up. And there you go, 4.98. My understanding is if that went to 7, then that means your potentiometer is bad, and that will send too much signal into your controller, and your controller will actually turn off. So that's what you want right there. Now I'm going to switch these and watch this. It's exactly the same. So either way, doesn't matter which way you hook these up to there, either way it's the same. Now we are going to test the M-Core 4. I've plugged this into here because I find it's easier to connect my alligator clamps to these leads than to hook them up into there. We are hooked up to the 0 to 5K in here. Give that a spin. That goes actually higher, 5.5. I'm going to switch the leads and we get the same reading. Okay, so we're hooked to the yellow, and now I'm going to hook it up to the white down here. Now we got 5.58. Now this is going to be going from 5K to 0. When you push the accelerator, it's going to go to 0. Which would work if this controller here was programmed for a 5 to 0, that would work. But this is programmed from 0 to 5K. So that would be not good. So that's what's cool about the M-Core, is it does 0 to 5K, 5 to 0. And it also does 0 to 5 volts. Now we're going to start hooking up the controller. I'm going to start with the lights. Now these are incandescent bulbs. Each one of these is a 12 volt, and they're run in series to give me a 36 volt resistance. I'm going to hook the negative right there to the M. We're going to hook the positive to here. That hooks up the load. Now we're going to hook up the solenoid. Now I've got a pre-charged resistor on there, a 10 watt, 500 ohms. It says on here to use a 5 watt, 250 ohms. So now we hook this positive to that side of the solenoid. Now we're going to connect this side of the solenoid. I'm going to go ahead and hook it right here. Now we're going to connect to the top connection there. And we're going to hook this over to here to get positive from here to the top here. For your controller to work, you've got to have positive coming in here. This is what tells your controller to turn on. We're going to connect the key switch. I've got a key switch here that came off of a motorcycle. Now everything I'm going to do with the key switch will actually be negative. I have a red wire here because that's what I had, but that will connect right there. So to turn the solenoid on, you've got to have negative here and positive here. So the negative side is going to be connected to this key switch. I'm going to use a green wire here. Hook this to the other side of the key switch, and that will connect to the negative. So the key switch is bringing negative from here to here. Now we need to connect positive to here. I'm going to grab some positive from here that's coming straight off the battery. So that's looping through there. Now this could go to your micro switch on your forward and reverse if you wanted. But that should. Okay, we had a little bit of sparks there. Here's the reason why. See, that's got a positive on it. These actually matters which side you go on. I think that's because it's got a diode in there. So you have to have positive this side, negative this side. So I switched it around, and now it works just fine. Turn that key switch on, hear that click. That's working just fine. So I am used to these solenoids. These don't matter which side you connect, positive or negative. Here we go, negative, positive. Hear that click? Switch these. Now we're going the opposite. Same thing. I want to show you how much voltage it takes to turn on the solenoid. The key is on. I've just got my wire here. So if I hook up to one battery, this would be 12 volts. You can hear a little bit of power in there, but it's not actuating. Now if I hook here, that's 24 volts. So somewhere between 12 and 24 volts in order to get the solenoid to turn on. Now we're going to connect the pop box. So we're going to take that top red one and the black that is connected with the red and the black. I'm going to connect these to these connections right here. Now that pop box is connected. Now we need to connect negative. Goes from here to our negative on the battery. Everything should be working now. Turn that key on. Hear that solenoid click. Grab our pop box. There you go. Success. That's how she works. See, that's a nice smooth acceleration there. We're just kind of going over concepts about how everything works. Hopefully it helps people troubleshoot some things. Here's another experiment. So these are all lithium iron phosphate batteries. You got one battery, give you 13.1 volts. Up to this positive. That's giving us 26.3. If I come up to here, Now up here is just raw cells, so you gotta be super careful with these because there is no BMS protection. And if I connect here, now we've got 2 batteries plus 1 cell. So we've got 29.5. Connect here, we've got 2 more cells, 32. Connect over here, we've got 36.1. If I connect here, I've got the full 4 cells hooked up here, 39.4. As you can see on here, this BMS fried. That was in my golf cart. It had 4 of these batteries hooked up and it destroyed one of the BMSs. Not a good idea. Now I'm going to show you how much voltage it takes to turn on the controller. So we've got 39.3 volts. That works good. Drop down 1 cell less, 36. We got nothing. That's what's weird about this controller. Like, see, if I go from this 39 over here real quick, then it works. So it can be a little bit finicky. Now if I go to the 39 volts, works every time. You jump to the 36 real quick, it works. Jump over to 32 real quick, it works. Jump over to 29, nothing. Back up to the 39, down to 29. See, no matter what I do, I can't get 29 volts to work. The controller won't even come on. So 39. So these controllers definitely work better the more voltage you have in them. So part of the problems people are having is probably that lower voltage. So touching here, we have got 39.3. Now I'm going to connect it down here and see how much power I can get. Well, the lights are on. This is coming out of the controller. 38.4. Now why I'm doing this is I'm curious if the M-Core 4 will put out a higher voltage than the pot box. Now I've got the M-Core 4 hooked up right here to the yellow and purple wires. 38.4. Same exact voltage coming out as the pot box. Interesting. So now I am connected to the yellow and white wire, which is the bottom prong here and the top prong. So both of the furthest away prongs, which is going to give you the 5 to 0K. So as soon as you turn your golf cart on, you're going full throttle. And you crank this down and you slow down when you push your accelerator pedal. So if your golf cart's going full throttle, something's programmed wrong. I've got a handheld coming so I can program this controller so it actually goes 5 to 0K. So it matches this, and then it would actually accelerate like it should. Okay, I know another thing that trips people up, and I couldn't wrap my head around it the first time, is you've got the red and the black together in the middle. So now I've got the black, outside black, hooked to the negative of the battery. Got the inside red hooked to my key switch. So now I'm actually running through the micro switch. Turn on the key switch, nothing. Push the pop box, you can hear that click, that's turning on the solenoid. And it is running the right ohms. Now we hook it to the controller and see if that works. See, with the key off, you got nothing. Key on, you got nothing. You have to have both because the circuit's running through both. So now I have it hooked up to the controller instead of the voltmeter. Nothing. Turns on. As you can see, I've got nothing. So that was a bad idea. I seem to have ruined something. Pop box is testing out. It's running the right ohms it should, but I turn it on. Now it's actually putting out volts, getting like 3 volts, and nothing's coming on. I think I might have ruined this controller. I don't know why on these pop boxes, why do they have the micro switch and the potentiometer hooked together right there in the middle? I don't get it. I can't figure out how to make it work. I don't know if any of you guys have figured it out. Drop a comment if you have, but I would definitely recommend just cutting them separate if you're going to use that micro switch. Well, I hope this answers some of the questions people have been having when it comes to building this system. I can definitely say that this is not going to work that well on a 36 volt lead acid battery golf cart, because the voltage is going to go low enough that this is going to be turning off on you quite often when you climb mountains and stuff like that. If you're going to do this test with 48 volts of power, you do need to add another light bulb, so you've got 48 volts of resistance. Otherwise you will blow out these 12 volt light bulbs. Now I'm doing this kind of wild without a fuse, so you probably want to add a 10 amp fuse here. I wasn't worried about because I'm using such small wires. I'm just melting wires. As you can see, I just melted that off of that alligator clip, and that worked as my fuse. But all in all, that was a pretty good, fun experiment. Now we're going to go out to the golf cart. We're going to install this M-Core 4. All right, let's tip this thing over. We're going to disconnect the V-Glide first. Slide that, see that? Slides forward, and then it just slides off. That's what locks it on. It's that easy, unless it's stuck. And then you might have to get some pliers, something like that. You got to move that. You might be able to put some WD-40 on there, but you got to get that loosened up so it works like this. And obviously, if you're just replacing your V-Glide, you're not going to take this one off. But we are replacing everything, so that has got to come off. To remove the V-Glide, you've got to remove these nuts right here, which is a 3/8 nut. And they're kind of a pain because of the angle there, but I've got a nice angled extension here. Makes that so easy. But reaching these from the top and trying to do it, it's kind of a pain. And there you go, the V-Glide is disconnected. Here's our M-Core 4. This is the adapter that's going to hold that. One thing I am noticing about this I'm not very impressed with. It seems like it's too small because it's hard to get this in there. These snap in, but not very easy. There we go. And then you put screws in here, but as you can see, these are not lining up like they should. You can get one in, and that one's off. Try to force it, I guess. Let's put those screws in. So this comes with 4 screws. You got the 2 smaller ones and 2 bigger ones. Smaller ones are for this. See, that one went real nice. Try this. Oh, look at that. That's bringing it in. Okay, that'll work. Take this piece and we'll put the spring on there. It's pretty obvious there's only one way that spring can go. We're going to put it down like this. And then we're going to slide it up here like this. And this goes over your accelerator pedal. Just like that. Locks onto there. Now we're going to slide this up into here. So as you can see, this golf cart's already got these holes pre-drilled out, ready to go. These are going to go into these holes, that one and that one back there. That shaft is going to go into here. Now we got one of those in. There we go. Both of those in there. See that? These snap in. Nice. Put these screws in. Now that's a 10 millimeter. And this one here, that came off. Bring it back around. It's going to go like this. So that one there is going to hold the spring. Get those started. The trick here is to get it tight enough, but not too tight, because these are just going into plastic. So you don't want to over tighten. That feels about right. There might be a torque spec on those, but I'm just doing it off of feel. There you go. Look how easy that was. M-Core 4 set up, hooked to your accelerator pedal, just like so. Now all we gotta do is plug the wires into there. Easy peasy. So now that we've got the golf cart tipped back on its wheels, we're gonna start looking at the key switch wiring. On this conversion, I'm going to try to keep as much of the original wiring intact as I can to try to make it as simple as I can. So this V-Glide is loose. The only thing holding it is the wires. As you can see, this micro switch right here has negative going through it. So we're going to connect the wires to go to this micro switch to the micro switch that's in the M-Core 4. And to do that, we run these two wires to the M-Core 4. So this one comes off of the negative here in the OBC. So we'll actually be changing that because we don't want to hook to that. We're going to find a different negative source, but we do want this one. So we will unplug this micro switch. We just need this green one. Pull that out of there. So this green will go to the micro switch, and then we need a negative source to go to the micro switch. The reason I'm pulling this all off is because I will be charging with a solar panel and I don't need it. And I think a lot of you guys aren't going to need this as well because you're going to be switching to lithium. I'm going to pull this front panel back. This one is missing the screws. If it had the screws, you'd have a screw here and a screw here you would be undoing to pull this out. The reason I'm doing this is just to show you guys the wires that are on the key switch. So you've got blue and red coming to the key switch. It's not going to matter which one goes where. And then you've got an orange and a white coming to your backup beeper, so you can have some annoyance in your life. So on this cart, here is your red that is hooked up right here where your main positive comes into your forward and reverse switch. From there, it comes down here, goes up to the key switch, then returns from the key switch on the blue, comes up here, connects to this micro switch. So this circuit needs to be closed in order to get power to transfer here, and which it does whenever you put it in forward or reverse, it closes that micro switch. And then from there, the power is coming down right there. Positive coming in here, negative coming in here from the MC4. That'll activate this solenoid, which will transfer the power. At this point, it's coming up to the V-Glide. So if you have a drop-down converter that has 5 wires and one goes to your key switch, this is where you're going to want to splice it in. Here, that'll give it positive when your key switch is on. You don't want to hook it here because then you will only have 12-volt accessories when you're in gear. Now we're going to remove the heat shield. I've got a 3/8 socket on here. We won't be needing that anymore. Got a 7/16 socket on here, and I'm going to remove all of the wires that are on the resistor coils. That got most of them. Got the 3/8 back on here. Take these out. They've got nuts on the bottom as well, so then you pull that apart. Now I'm going to disconnect this wire from going from the V-Glide to the solenoid. The reason why is because I will need a longer wire on here. Now I'm going to remove the wires off the V-Glide so I can reuse them. Before I get started on the wiring of this solid state conversion, I want to thank everybody for watching my first video and commenting on it and using my links to purchase products off of eBay. So eBay has been really good to me because the way their links work If you click on one of my affiliate links below the video, then it brings you to eBay, and eBay pays me basically just to drive traffic to their site. So anything you buy on eBay within a 24-hour period, I get a percentage of. Even if you don't buy what you clicked on, thanks for all your support. It made this video possible. So I found a better manual for this video. I'll have a link in the description. This one's got a lot more detailed information in it, and it's more about the controller that we're actually using because it's this exact controller. It does have the J5, which is a reverse function on there. So we're going to be using page 10 in this new manual, and we're going to start with the armature. This is a stock motor. It is 36 volt series motor. As you can see, all 4 cables going into it are the same size, and it has the armature A1, A2, and then it's got the field S1, S2. So that's how you know it's a series motor. Same size cables, and it's got the S1 and S2. What I like about this motor is it does have great big lettering, which is going to be easy to see. So I've got the bracket I made set into the cart here. I'm going to be using the controller out of my first cart because I did burn something out when I was messing with these with the pop box and connecting negative power to them. Something on my new one is fried. I'm going to try to connect as much as I can to this controller with it sitting like this so it's easier to follow. But when it's all said and done, this controller will be mounted on here like this. As you can see on here, A2 is connected to the A2 on the armature, and it is also connected over onto the forward and reverse switch. So here we have A2 from the motor connected there. So right now, the way this is wired, we've got S1 coming into the top of the forward and reverse switch, and so we need to take this off of here and find a different wire. We're going to take that all the way out. You want to clean all your connections when you're doing this. Spiffy new. So it looks like this yellow wire will be the right size for running from the controller over here to the forward and reverse switch. So I'm wiring this way. I'm going to bring in the M1 into the bottom and the A2 into the top. It probably doesn't matter if you do it this way. We'd probably do the same thing. But I'm going to do it like that because that's how I did my last one. Hook this up. Bring the other side over to the controller. Actually, I want to turn that like this so that the flatter side is against there. There we go. Just going to have to find whichever bolts you can for this. I'm just using some stainless steel bolts I had on hand already, which seemed to be a good size for this. Now we're going to connect M1 to the bottom of our forward reverse switch. I'm going to connect it right here. So we've got to take this nut off. So I've got a fatter wire hooked on here that I hooked on here when I was burning out the V-Glide. This one right here is that I hooked to my positive. So pull that out. And now I've got this positive going to the key switch. That's going to need to go somewhere else. I'm going to connect this back up because this does need to be looped between these two. This is 36 volts for forward, then this is 24 volts for reverse. But how we're doing it, we need both of these connected together. So you could put a bar across here and connect these together. I'm just jumping with that for now. Put this green wire on there. Run the other side of the green wire over to here. Going on the M1. And then you'll just snug these down. Now I'm going to connect S2. As you can see, this is hooked directly onto the motor right here, S2. We're going to be connecting right here. That's the same way it's connected on my other golf cart. So this wire right here is actually going back into there, and it is connected to A1. So as you can see, this is quite a bit different how we're hooking it up this time. It's got kind of a silly little piece of metal they had on there before. So we'll put it back on. Just like that. Then you're going to want to tighten that up. Time to do S1. As you can see, coming off of there, S1. These cables are nice and long. That's going to go right here. So we're going to disconnect that and then put that there. As you can see, I'm cleaning all my connections before I hook them up again. I clean this as well. Okay, you're just going to want to tighten that up. Now we're going to connect to the battery positive on the controller. An A1 connects there. Here's A1 going back. Right there, A1. So we connect that on here. And we're also going to connect another wire to go to our positive battery. So your second wire coming off of your battery positive right here is going to connect to your solenoid. Now this hole is not big enough to go on the solenoid, so we're going to widen it. Now always, safety glasses whenever you're using power tools. I like to use these pair of vice grips to hold it, and I find this is a really easy way to make those holes bigger. That's plenty big. So you notice these wires, they've got two different sizes on a lot of them. They've got a small end and a big end. So if you're going to drill one out, you can drill out the big end. There we go. Let's put that on there. So your solenoid, it does not matter which side you put these on, as long as you put them on there. I'm just going to kind of put that on finger tight for now, just so we don't lose our wire, because we do need to put our capacitor on there. Now we're going to connect our negative onto here. So this is how many wires I have left. Now these are 6 gauge wires, or 6 AUG, whatever you want to call them. They're good for 55 amps, so they're really undersized for what we're doing. So it'd be a lot better to get these bigger. Now if you're just going to drive around flat streets around your neighborhood, you probably could use these, but if you're going to climb any kind of hills, they need to be bigger. But I'm just showing you what you can do with the existing wires. So 4 AUG is going to be good for 85 to 95 amps, which would definitely be a lot better. But since all these are in such bad shape, I'm going to use this big fat one here to run my positive. I'm not sure what size that is. It's a welding wire, 600 volt, 50 millimeter. That's definitely heavy duty. So now we're going to talk about the solenoid. That's what we're going to be wiring now. So we're going to take this back off, at least the nut back off. I'm going to put these here and probably lose them. So this manual is really nice. This new manual I got linked for this video. It got so much more information in there. See, it actually tells you what size pre-charge resistors you need according to the voltage you're going to be running in your cart. Now we're going to be running 36 to 48 volts. So this actually says a 10 watt, 250 ohms. They've got 250 ohms on all of them. You'll find that these numbers change a bit on different carts, but I'm going to be running this one right here, which is a 10 watt, and it is actually a 500 ohms. I'll put a link in the description for these. We'll put our big fat cable on this side. Now you always put your heaviest cables closest to the power. And then we'll put our resistor on there, put these nuts on there. So this cart does have a diode on there. First cart I did, I researched, and best I could come up with was the diode. You only needed it if you have regen, but this new manual does show a diode on the solenoid. Southern nut on there. So pre-charged resistors are very important to have on here. I'd say it's one of the most important things on there. So what the pre-charged resistor does is a couple of things. For one, it helps your solenoid last longer because it's putting power across there, and so you don't have a spark when this engages. And then the other thing it does, it's pre-charging your capacitors in your controller. Think about capacitors in your controller. If you went straight on, full power, you'll pop those capacitors. I've done it, so I know. Not a good idea. So these pre-charged resistors are very important. So I put some red tape on my positive lead. There's my negative. I've just got to hook a battery, positive, negative to these. Either a 36 volt battery or a 48 volt battery. Doesn't matter. Either one can run in this cart. So now my plan is I'm going to jack this up, get the rear tires off the ground, and we're going to test this system to see how it works. Got the golf cart up on jack stands. We're hooked up to the lie time on the easy go, positive, negative. Coming on over and connected to my negative and positive. Coming on in. So this wire here would be bringing in power from the pedal micro switch. I have bypassed that with this black lead that's coming up and connected directly to my controller right here, where I've got the negative coming in from the battery. So that's supplying negative to the solenoid. Battery positive comes in here, and this is hooked to the controller. So the only way to get positive into my key switch is to connect here. So this wire connected to the key switch, and then the power is coming back from the key switch up into here. And when this is activated, then it's bringing the positive down to here and turn on the solenoid. And that's why I've got this jumped from your solenoid positive up and onto the positive of the controller. And then these two, which is your potentiometer readings, going to your pop box, which I have coming over here and just hooked in this pop box for testing purposes. Let's see if it works. Key switch on, into forward. Can hear that solenoid clicking. There we go. Forward works. Now we'll switch it to reverse. You hear that solenoid turn off, back on, just like it should. We've got reverse. For this test, I'm using 38 volts, but when we take it for the road test, we're going to put 48 volts into it. So the way it's wired right now, you've got the same speed in forward as you do reverse. I have already wired in the key switch. I'll just run you through it how I did it. I've got the red wire hooked right here to my main positive coming in, going to the key switch. Then it's coming back on the blue wire and going up to this micro switch, which is of course going to come down to the solenoid. But I have spliced in on the blue line right here, ran this red lead up to here and plugged it into the controller. So whenever the key is on, this controller is going to be on. Your golf cart's only going to drive when you've got this in your forward or reverse, because that what turns the solenoid on and off, which actually puts power into the controller so power can come out of the controller. But my theory is just have it on whenever the key's on. But you could actually hook this wire up on this side of the micro switch, and then it would only be on when this is selected. That's also where you're going to want to hook in your drop down converter if you have one with the keyed on and off. If you don't, then you just hook it in to the best positive and negative you can. Now we're going to hook in the M-Core 4. So here's the connector that came with the M-Core 4. I'm going to cut these. I'm going to cut them right in the middle because I might want to use this for something sometime. But we are going to use the yellow. Well, it's yellow and green. And then you got the purple, which will give us 0 to 5K. I'm going to use a yellow wire for this because I'm going to use green somewhere else. What I like about these is they've got their different colors right on there. It shows you where to clip your different color connectors. But gonna poke this down right here. It's all said and done, I'm gonna actually put this into here. Put these wires down here. I'm gonna take these, I'm gonna push them up here because I want them to come out right there. Then I want them to come over, probably along that rail, over, up underneath to my controller. I'm guessing right there. I crimped my ends on here, but before I connected to the controller, I wanted to test it. Got it hooked to the voltmeter, as you can see. I've got it on the ohms. I'm gonna push this, and there you go. It's working like it should. It says you're gonna come down like 2 inches before it starts engaging, and then, you know, 4.3. So it's not quite getting all of it. I wonder if there's some adjustment I can do there, because it would be nice for it to catch sooner. Now we're going to connect it to the controller. Now remember, it doesn't matter which one goes where. Those are pretty tight. It's good that they're tight. Okay, that is all hooked up. Now it's time to do the micro switch. So I've taken this other connector that came with the M Core 4, cut it there, crimped on a blue and a green wire. Now we're going to feed this down and plug it in. So you've got a red and a green coming up here now. I'm going to connect the blue. It really doesn't matter which one you connect to what, negative or to the solenoid. But I'm going to use the blue to hook to my main negative. And for me, the main negative is going to be right here. So I've just got to string this down, along there, up over, so it can connect. So probably about here. I'm just going to cut that. Strip that. And I've got some nice big ended connectors here. I'll put a link in the description. I'm going to use that one right there. I've got this other assortment here, but it doesn't have anything big enough to go onto the bigger connectors. But see, that's for a small wire. Give that a little tug. Yep. Okay, so that will come over and connect right here. So I'll need to take that off, put that on there. But you get the idea. Now this one is going to come over this way, pull it down. There's 2 ways you can do this. You could put a round connector on there and connect it right there on that solenoid, or you can cut that wire and splice it. I'm going to cut this wire and splice it. Now I'm going to rip this whole thing out because I'm going to be charging this with a solar panel, so I do not need any of this. But if you're going to keep this, you're going to wire your cart a little bit different. You hook your positive and negative up on your battery there, and then you're actually going to want this, or you could go either way, but you could actually connect it right there if you wanted, but we're not doing it that way. So right here is your J5 connector. This is, so you have a lower speed in reverse. From everything I've read, you can put the same voltage into here, so 36 or 48 volts coming into here, and that's going to tell the controller you're in reverse, and now it's going to go slower. But you need some kind of power source to go in there. I'm thinking the best way to do it is put another micro switch right here. You just drill some holes and bolt one right here so that when you're in reverse, you can connect that over to there. But you do need to have a handheld programmer to program this so that the reverse function does work. And I'm going to do that, but I'm going to do it in a separate video when we actually take this cart to 72 volts. I'm definitely going to want to drop down that reverse speed for that. So at this point, I'm just going to tidy everything up. Got everything bolted in. I've even gone underneath and taped up those wires and put them in that sleeve, so they're good to go. I've mounted the controller on the plate that I built. I've got it hooked to my big battery, Husky 2. This is the battery we used when we burned out the V-Glide, so it's a good battery to test. That battery would fit in here if you wanted to, but that battery is actually not the one that's going to be staying in this golf cart, so that's why it's just kind of temporary wired in for this test drive. I did notice that this cart definitely does go slower than my 91 club car, but they got different motors. You see this motor here? The inputs are in a line like this. In my 91 club car, the inputs are in a line like this. So it's a different motor, and that's why I got different speeds. But all in all, that was pretty slick. Now obviously, I just did everything with existing parts because I know some of you guys are going to be like, let's just use the existing parts because we have them. And so this is what happens when you use existing parts. I'll test and see how long they go. But obviously, if you're climbing a lot of mountains and all that, heavier duty wires, upgrade everything. I would definitely put this solenoid over here. That's my plan when this one burns out. So I'm gonna see how long this 36 volt solenoid lasts. All right, time to go up the mountain. All right, here we go. One thing I really like about the solid state is definitely a smoother acceleration. It's definitely not going as fast as it did with the V-Glide. That's disappointing. I might have to do some setting adjustments using 64 amps, 66. Well, this road's a little rougher than it was when I burned out the V-Glide, that's for sure. So 105 amps, that's the most I've seen this use. So I do think some adjustments are off a little bit. I think I'm gonna connect my programmer to this and fine tune it, and we'll try it again. That gives you an idea of how it drives straight out of the box. So I hope that helps some more of you guys get your golf cart converted up to solid state. I'll probably do a update video where I fine tune the settings on this and see if I can get some more speed out of it. But thanks so much for watching. See you guys all next time.